Today we are here to present our STEM project that we have designed in order to present in the STEM Fest. And we have three group members. Myself, Rigzin Leto from AMID first year mathematics, and we have Choni Wanchu and my colleague Kingonam Gisring Tama. So our topic of the model was electric power generation using wind turbine. So as a teacher, it is important to use in mathematics especially, or in terms of PBE, place-based education. It's important as a mathematician or mathematics teacher to bring some cross-pollination of the subjects in the classroom. So that's why as a mathematics, we're trying to integrate that concept using electric power generation and how mathematics can interpret this model in terms of mathematics. So here, if you think of a concept, it is just using a dynamo as the principal focus of generating electricity, where you see this real life example in Wangdi. So we are trying to bring Wangdi in Samti, especially because we cannot move our strengths or take these strengths of ours to Wangdi to show some basic concept of how this particular generation of electricity take place through use of renewable energy such as wind. So this is mainly for teachers who aspires to bring this concept to the class through a model. So in this model, what we are trying to use is we are using Faraday's principle, where physics can be also incorporated inside this concept. Faraday has discovered that when a magnetic material is being moved under the influence of magnetic force, it tends to induce some current in that particular magnetic substance between this magnetic field. So in this especially this area, it is called as dynamo. There it has this principle, it is shown in this picture how it generates electricity. So mathematically how we represent it is we have factors like external force, which is called as wind. We have this material inside this called as armature. We have magnetic field which is surrounding this particular dynamo. So when it rotates, it tends to generate electricity. So this Faraday principle is being used, and this mathematically how we are trying to interpret is through some formulas being developed by Faraday's law. So when the wind blows from here, it tends to rotate this fan, and when the fan rotates, it tends to cut the flux of that magnetic field, thus inducing some current in it. So this produces a DC current, a direct current, and we have a wire inside this particular field that we have developed, and then it is connected to this, and later on I will show you how it really works. So this is the basic principle behind this electric power generation using wind turbine, and the takeaway from this particular model is, as a student in Samti especially, it is a very windy place, and we have so many places where you see continuous flow of wind or strong wind like Damdum, especially in the viewpoint especially. These are some of the places where you see a continuous flow of wind. There, as a student, how you can take this idea to create some very meaningful application, like using this particular dynamo. It is made up of it generates 12 volt of current. So this is enough for generating 5 voltage for mobiles. So you can create a portable mobile charger using this concept. So this is the final takeaway for the students. So let me take you through how this particular model works. So we tend to use this as an external force to generate electricity. So let's imagine that this as a wind energy. So as you have seen, when we rotate this particular turbine, Faraday principle has been used in order to generate some electricity, and this electricity is passing through this wire which is hidden inside this particular module, and then it is directly connected to this LED bulb. So this is how it can it proves that Faraday's principle is true. Mathematizing this concept, if you read through this particular handout, you'll understand how it is being produced and how much energy of wind is being used. So this model is to integrate all the subjects together, and this can be some of the methods as a teacher to demonstrate every subjects coming together and explaining to the students. And this is how we can, as a teacher, use cross-pollination concept as well as in math, as well in physics or any sort of subjects, and especially in geography. This is very relevant. So that's all, and thank you very much for listening.